So in this lesson 1-7, we're going to talk about three-dimensional figures and some vocabulary that we need to know for these 3D figures, kind of an overview before we start looking at each individual one. So a solid with all flat surfaces that enclose a single region of space is called a polyhedron. Each flat surface or face is a polygon. The line segments where the faces intersect are the edges. The points where the three or more edges intersect is called a vertex. And these below are some examples and definitions of polyhedrons and other types of solids. So we have a prism, which is a polyhedron with two parallel congruent faces called bases that connect. Pyramid is a polyhedron that has a polygonal base, and that base can change shapes, and three or more triangular faces that meet at a common vertex. These are not polyhedrons, cylinder, cone, and sphere, because of their curved parts. So we have a cylinder, which is a solid. It's got congruent parallel circular bases connected with a curved surface. A cone is a solid with a circular base connected with a curved surface to a single vertex. And then a sphere is a set of points in space that are the same distance from a given point. A sphere has no faces, edges, or vertices. So we've got some shapes we can name here. So polyhedrons or polyhedra are named by the shapes of their bases. So we look at what that base shape is, and we can name it based on that. So we see that this base is a triangle, and we see the other side there is also the parallel and congruent same side. And so that would be, it's a prism, so we call it a triangular prism. I'm going to use a triangular prism. So this next figure, it has a square base, so we can kind of see, we look for, again, it's two matching bases, and then we look at that shape. In this case, it's a square, so we would call that a square prism. Yes. So we need to pay attention to whether something is a prism or a pyramid or one of these three non-polyhedrons. So in this one, I can see that I have a five-sided base, which we call something with five sides, a pentagon. So this would be a pentagonal prism. Pentagonal prism. Okay, this next one has a triangular base, so we again look at the base for naming it, and it is a pyramid. We're switching to our pyramids here, so this one is a triangular pyramid. We then have a square pyramid next. And then lastly, if you want to identify that base and shape, hopefully you were thinking it is a pentagonal pyramid. And there are those figures. So we have a polyhedron is a regular polyhedron if all of its faces are regular congruent polygons and all of the edges are congruent. There are 5 types of regular polyhedrons, and they are called platonic solids. It's an L. Because Plato used them extensively, and here they are. A tetrahedron, a hexahedron, which is a cube, octahedron, dodecahedron, and icosahedron. All right, so we're going to go ahead and identify whether the solid is a polyhedron, and we're going to take a look at faces, vertices, and edges of our figures. So this first one we have is a base here of a rectangle, so it is a rectangular prism. So then we have, is it a polyhedron? Yes, it is a polyhedron. And name the bases, faces, edges, and vertices. Well, we're going to go ahead and name how many we have, and then we can practice just a couple of them. So the faces, this is a face, this is a face, this is a face. We have a face or a base on that side, we have a face there, and then we have a face on the bottom. So if we count up all of those faces, we have our bases 1 and 2, because those are still considered faces. And then we have 3, and then our top 4, and then our side 5, and then our bottom 6. So 6 faces, and if you were naming them, you'd name them G, E, F, H, that's one face, G, H, D, C as another, or C, D, H, G, however you wanted to go, but you'd go in order around if you were naming them specifically. But we're just going to count them up. Edges, so we have an edge here. So there's one edge, and then we've got edges going all around there. So there's 4, and then 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 edges. Vertices are the points where those edges are meeting. So those would be all of those labeled letters are vertices. So there's 4, and here's another 4, so that makes a total of 8. All right, so if you want to try those last 2, you can, and then push play and check when you're ready. So this one is a polyhedron, and it has a 6-sided base, so it is a hexagonal prism, and it has 8 faces, 18 edges, and 12 vertices. Cone, not a polyhedron because it's got that curved edge. And then we have one face. It is the bottom here. It's a flat surface, so that's one face. We don't have any edges because there's no straight lines meeting there. And we have one vertex point up here at the top. So one there, and this was a cone if we were naming it. So surface area is the total area of the surface of a 3-dimensional object. So the total area of surface of a 3-dimensional object. Now the volume is the amount of 3-dimensional space something takes up. So again, surface area is the area, and volume is the amount of 3-dimensional space something takes up. So we are going to look at each individual 3-dimensional object, not doing all of this all at once. So just kind of giving you an overview right now. We have our prism, we have our regular pyramid, we have our cylinder, and we have our cone and sphere. Okay, and then we have each individual formula, which we're going to be looking at in each separate unit and giving you some practice with those. So a net is a pattern that you can cut and fold to make a model of a solid shape. So we've got 2 examples of a net down here. So what would this, if we cut it out and folded it up, it would make a cube. And what would this one make? A circular base, and then this is going to wrap around, meeting at a vertex point, a cone. So those are examples of nets. All right. So then we have what's called a cross section, and a cross section is a view into the inside of something made by cutting through it. So we've got a cross section here. Well, all we're seeing that it's cutting through is a point. And then here we can see that cross section is making what shape? A pentagon. So you can kind of see what that shape is with that cross section.